Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, in a previous video, we went over how to find empirical formula and molecular formula of a compound. Today, we're going to learn another way of trying to find empirical formula. We're going to do it using combustion analysis. What is combustion analysis? Well, let's go to my screen. So, combustion analysis, it is where an unknown compound undergoes combustion, burning in the presence of pure oxygen. When this combustion reaction is done, we're going to get carbon dioxide and water. So all of the carbon from our hydrocarbon converts to carbon dioxide, and all of the hydrogen from a hydrocarbon converts to water. And here is a picture how it works. You put your sample, and oxygen is pumped in. You can see where the oxygen is pumped in. Here it is. And this hydrocarbon will be heated up, burning, and you're going to get water, and you're going to get carbon dioxide, and then the rest of it comes out. Let's actually do this. Here is our problem. Upon combustion, a 0.8233 gram sample of a hydrocarbon, it contains carbon, hydrogen, and oxygen, produces 2.445 grams of carbon dioxide and 0.6003 grams of water. Find the empirical formula of a compound. Well, what are we trying to do? Let's do this. We are trying to find a formula of this compound, C, H, and O. We're going to have X here, Y, and Z. We are trying to find the subscripts. Okay, let's think about what combustion reaction is. In this reaction, our compound, and OZ, is going to burn in the presence of oxygen, O2, to make carbon dioxide plus water. Here it is. I don't have much to go on. I only know the mass of a sample, so let's write what we have. I have 0.8233 grams of my sample. I do not know how much oxygen it's going to use, and I'm going to produce 2.445 grams of carbon dioxide and 0.6003 grams of water. How will this help me? Let's think. In empirical formula, I knew either masses of my elements or I knew percent composition by mass. How can I get that information? Well, let's look at our equation, and we realize that all of this carbon had to come from this carbon. This is the same carbon. And then we realize that this hydrogen in water could only come from this hydrogen in a sample also. Oh, so now I can do stoichiometry and figure out how many grams, the question is how many grams of carbon are right here in this sample, and how many grams of hydrogen are in this sample of water. Once I know that, I can go to the next step. So let's try to figure out, let's deal with carbon dioxide first. So here we go, my carbon dioxide first. Okay, I have 2.445 grams of carbon dioxide. I'm going to change it to moles. 1 mole of carbon dioxide is, well, I'm going to use 4 sig figs, 44.01 grams of carbon dioxide. There is 1 mole of carbon in the sample per 1 mole of CO2. And now let's figure out how many grams of carbon, and we have 12.01 grams of carbon per 1 mole of carbon. And if we do this calculation, we're going to realize we will have 0.6673 grams of carbon left. Let's squeeze in that carbon. Let's do some calculations for water, for H2O. So how many grams of water do I have? I have 0.6003 grams of water times 1 mole of water is, well, it's 18.02 grams of water because hydrogen is with 1.01 gram. Now, there is 2 moles of hydrogen per 1 mole of water, it's H2O, and we're going to say there is 1.008 grams of hydrogen per 1 mole of hydrogen. And if we do these calculations, we're going to see that we have 0.06715 grams of hydrogen. Okay, so now let's think of what we have. Our compound has carbon and hydrogen and oxygen in it. Now we know the mass of carbon and we know the mass of hydrogen. So if we take our mass of compound and we subtract the mass of carbon plus hydrogen, we are going to be left with mass of oxygen, right? So let's do this. So our compound was 0.8223 grams. And if we subtract, well, if we're going to add these two numbers together, we're going to have that this is 0.73445 grams is my carbon and hydrogen added together. So minus 0.73445 grams, I'm going to be left with 0.0885 grams of oxygen. Wow, that's great. I have my masses now of carbon, hydrogen, and oxygen, and I'm ready to do the next step, which is just to find the empirical formula. So this will be straightforward. So let's do it. So I have 0.6673 grams of carbon. I have 0.06715 grams of hydrogen, and I have 0.0885 grams of oxygen. Let's change these to moles, right? 1 mole. Let's do a quick erase to make this all nice. So 1 mole of carbon is 12.01 grams of carbon. Hydrogen, 1 mole of hydrogen is 1.008 grams of hydrogen. And my oxygen, I'm going to say 1 mole of oxygen is like 15.999. So I'm going to use then 4 sig figs, 16.00 grams of oxygen. And when we do these calculations, we're going to see that we will have 0.05556 moles of carbon. We're going to have 0.06662 moles of hydrogen, and we're going to have 0.0055553 moles of oxygen. Be careful with these zeros. There is a common mistake that students skip the zeros. Watch out, there is the extra zero in oxygen than carbon. The next step is we're going to divide by our smallest number, which is the moles of oxygen. So we are dividing it by 0.0055553, because these are ratios. 0.0055553, and we are dividing this by the same number, 0.0055553, and we're going to get this as 1. This will be, you can clearly see it's going to be 10, and this is going to be 11.99, so I'm going to say 12. So there we go. So the empirical formula of our hydrocarbon is C10H12 and O1, and we don't write that 1. So here you go. And this is how you get empirical formula of a compound using combustion analysis. Thanks for watching.